number 2, start by distributing. We have 8 minus 6x minus 18 is less than 4x minus 5. Combine your like terms on the same side. And then move all of your variable terms to one side, your constants to the other. So let's say I add 6x and add 5. So that we get negative 5 is less than 10x. And when you divide, you would end up with a fraction or decimal. You could leave your inequality like this or flip it so it's easier to look at. And then everyone in this room could do the number line differently. How you did it doesn't matter as long as it makes sense. So if you wanted to just put whole numbers and put this in between, that's fine. If you wanted to use decimals, that's fine. If you want to do a mixture, that's also fine. It really does not matter. So let's say we started at negative 1/2, and let's say I just wanted to use whole numbers after that. So I start counting. As long as it's in there somewhere and you can see it, it's fine. And then greater than 1/2 would be open circle going to the right. So as long as yours matches to some degree, then it's fine. Questions on that one? Number 3 is asking which of these fall in the solution set. So you would have to solve this first. So this would be 6 minus 10x is less than 8x. Get all your variables on the same side. And divide, again getting a fraction. So from the answer choices, look and see which ones are greater than 1/3. Would negative 1 work? Negative 1 greater than 1/3?
No.
Would 1/3 work?
No.
No, because it's not equal to. Would 1 work? That's 2.5.
Yep.
So this is kind of like what I said the other day. Use other numbers around it to check and see, are you going in the right direction? Right. And then number 4, as you were solving it, you may have seen something that was similar to like a no solution, but that's not what we're going to call it here. So solve it like normal. So we can combine our like terms and distribute. Get all the variables on one side, constants on the other. So when we do that, or in the way I did this, both of these cancel, just leaving 0 is greater than 15. So here we really have to see, is this a true statement or not?
No.
So we would say it's false. Right, but we won't be dealing with problems like this. We'll see more that actually have a solution. Questions on any of those? Is 0 greater than 15? It's not a true statement. Okay. So everyone should have these notes in front of them. write down this definition. So last class we talked about multi-step inequalities. Today we're talking about compound inequalities. So that is two inequalities or more joined together with and or. And then we're going to talk about the differences between these and some examples. Anyone still writing this definition down? So let's start with or. Or inequalities in this class, for our quiz, for our test, for our practice, have a tendency to graph apart. And you'll see what that means here in a second. So let's say we solved our inequalities and we got these two as our answers. X is less than -2 or x is greater than 3. We would graph those like normal. So closed circle going to the left, and then open circle going to the right. So you can see that they're graphing away from each other, graphing apart. Then we would write our interval notation. So from last class, looking at this left to right, it starts at -infinity. It stops at 2, and that would be a bracket, -2, sorry. Then we would write the word or, keep going. It starts again at 3, but that would be parentheses. And then it keeps going towards positive 2. So it'll be a little bit more than what we did last time. Before we actually use that in an example, do we have any questions? So let's try number 1. So with our or inequalities, we're going to solve them separately. What you do to one, don't do to the other unless they're exactly the same. So for this first one, and it doesn't matter which one you do first, we would add 4 to both sides. For the other one, we would divide both sides by 2. After you find the two inequalities, you're going to write the word or in between them. So that would be your inequality answer. Then we would graph that. Open circle at -3, going to the left. Closed circle at 6, going to the right. And if we're writing that interval notation, how would that look?
Comma, -3 bracket, no bracket.
For this one, it would be parentheses, because it's open.
And then 4, bracket 6, comma, parentheses, infinity.
There is a parentheses at the end of that. It's just really close to the end of the board. Okay, questions on that one? So far, the compound inequalities aren't difficult. There's just now two of them that we have to solve and graph and all these things. Okay. Let's do another one of these. Do number 5. So the one on the left, I'm going to show you 2 different ways you could solve that one, but we'll do that here in a moment. So let's solve them both like regular. Distribute negative 6x minus 3 is less than negative 15. I can keep solving this. Add 3 to both sides to get negative 12. And then divide both sides by negative 6. Remember that if you're dividing by a negative to both sides, your sign changes direction. So that would be one of them. And then go back and solve the other. So we would subtract 1. This is really negative 1x, so divide both sides by negative 1. And again, flip the sign. And then when you're writing that final answer, you can write it one of 2 ways. These aren't like lined up, so I can write or in between them and draw arrows. Or if you want the one that's less than on the left so that it's in order, you can rewrite it. Either or does not matter. So then we would graph both. Closed circle at negative 4 going to the left. Open circle at 2 going to the right. The interval notation for this one would be what? Close.
Or parentheses, no.
Yep,
Right.
you're right.
No.
Parentheses.
2, infinity.
Do we have any questions on that one? Once you've written that down, oh no, sorry, before that, I'm going to show you the other way. So you can write this down if you want. You don't have to. We're going to write this one on the left in this open space. So this would be the second way on how you could solve this. Instead of distributing, if I see that negative 3 goes into 15, I could divide them both by negative 3. I can divide instead of distributing. But because I'm dividing by a negative, my sign would change directions. And then I would solve it from there. So you would get the same thing either way, as long as your math is correct. Questions on that one? So again, that only works if you can divide that number and not get a fraction, get a whole number. If you divide and get a fraction, don't do that. Yes. Great. Go on to the next page. Everything you know about or inequalities will be different for and. They're like opposites. So if or inequalities have a tendency to graph apart, and inequalities have a tendency to graph together. And then the example, if we draft both of these, x is greater than negative 6 would be a closed circle at negative 6. Sorry, negative 6. Going to the left, going to the right, sorry. And then x is less than or equal to 1 would be closed as well, going to the left. So for and inequalities, we're looking for where do they overlap?
Negative 1.
Positive 1 to where?
Negative 6.
So as you're practicing, if you want to keep doing the 2 arrows and then draw out where they overlap, that's fine. Eventually, I really just need where do they overlap. So if you just do the 1, that's fine. If you do all 3, that's also fine. So when we write our interval notation, we're only looking for where they overlap. So it would start at negative 6, it's closed, so bracket, and it would end at 1, closed, so also bracket. So these will not have infinity, negative or positive. Then the other thing with and inequalities is because they usually fall between 2 endpoints, they're written in a more condensed form. So we would take these 2 inequalities, I'm just taking the ones from above, and write them as, start with the lowest number, negative 6. You're always going to have less than or equal, less than or less than or equal symbols, depending on what's given. X is going to be in the middle, another symbol, and then your other number. So they say the same thing, just one is more condensed. Questions so far before we actually use that to solve? Alright, so let's try number 6. Here, where or inequalities, you solve them separately, and inequalities, you solve together. So whatever you do to one, you do to everything. So our goal is to get x by itself in the middle. So we would get rid of the 4 by subtracting, but do that to all sides. So we end up with negative 2 is less than or equal to x, which is less than 5. Our and inequalities will already be set up like this, so you don't have to condense them. So you could start off by just graphing this. Start at negative 2, that would be closed. It ends at 5, but that would be open. And connect the line between them. If you still wanted to see where they overlap, you would do 2 different things. Look at just the last part. X is less than 5. Graph that part. Then look at the other piece of it, but read it backwards. X is greater than or equal to negative 2. And you can see that overlap happen. The arrows piece is not necessary. This piece with the endpoint is. And then what would our interval notation be? Where does it start? Negative 2. So not parentheses because it's closed. And at 5, would that be parentheses or bracket? So some of these could be parenthesis, bracket, bracket, parenthesis, bracket, bracket, parenthesis, parenthesis. going to be a mix. Could be a mix. If solving altogether confuses you or it's too complex, you could separate this so that you have one piece of it and then the other, and solve them as two separate inequalities, and then at the end still combine them. So if you solved it like this, you would still get the same answers. You would have x, you would have basically this part here and this part here, and you would end up having to draw everything. So just keep that in mind. Questions on that one? We're going to do one more of these, and then any others you guys want to see, and then do some of the time happy. So you can see what that looks like. So let's do number 10. So this one also has two different ways you can go about solving it, so I'm going to show you one afterwards. We could start off by keeping. We have negative 2 is less than 2x minus 12 is less than or equal to 4. And then how would we start to solve this? Add 12 to everything. So we have 10 is less than 2x, which is less than or equal to 16. Divide everything by 2. Before we graph this and find the interval notation, I just want to point out something else. What would happen if this was negative? I'm going to do this off to the side just in case you see this. So I'm going to use this but change the middle to a negative. I would still divide everything by negative 2. So we have negative 5. Then all the signs would change. But we still want this in order least to greatest, and we want them as less than or less than or equal to signs, so we're going to take this and flip the entire thing. So if you did get a negative, that's what you would do. Change all your signs and then flip the entire thing. Questions on that? So we can graph this from 5 to 8. Open circle at 5, close circle at 8. Some of the lines are going to be smaller than others. And what would our interval notation be? Where does it start? Where does it end? Starts at 5, parenthesis or bracket. And then 8 ends at 8 with a parenthesis or bracket. The other way you could do this, so write this where you have space. You don't rewrite it. Is just like the problem with the 3 and the 15. I could divide all of these by 2 because they're all divisible by 2. So I'm going to do that first instead. So we have negative 1 is less than x minus 6, which is less than or equal to 2. Then you would add 6 to everything. get 5 is less than x, which is less than 3. So you could do it either way, as long as you're actually able to. If there was a 2 in the middle, but like a 5 and a 7, probably don't do that. You'll end up with fractions. Not that you can't do it with the fractions, it just may be harder. Questions on this one? Find any problems on this page, on the last page that we did, on the very last page that you want to see, go over, have questions about. Jenny. 9 on this page or that one? On which page? Any others? So we have 7 on the very last page, 9 on the page we were just on. Brian? Yeah. Any others? 9 on which page? This one? Alright, so let's start with 9 on this page and then do the other one. For this one, it's written in the and format, and that's on the and page. But that's how you know it's going to be and, so we're going to solve it all together. Subtract 1 to everything. How would I get rid of that fraction? We could divide, but instead of doing that, what else would we do? Multiply by opposite? Yes, the reciprocal. Take it, flip it, and multiply that on both sides. Thank you. So that would give us negative 6 over 2 or negative 3. X is less than or equal to 12 over 2, which is 6. And then graph that. So open circle at negative 3, closed circle at 6. What would that interval notation be? Questions on that one? And then once you've written this down, turn over to the back so we can do 7. The way this is written, is this an and or an or inequality? And. It's condensed. If it said the word or, that would tell you it's an or inequality. Right, so for this one, we would solve it all together. Get rid of the 1. Divide everything by 9. Negative 6 is less than x, which is less than negative 3. So both would be open circles. It would be short. And how would we write that interval notation? Yep, just like that. Any others we want to see, have questions about, want to go over? On the very back of your notes, write this down. So negative 9x plus 5 is less than 17, and 13x plus 25 is less than negative 1. So first, notice that these are two separate inequalities and not like ours where they're condensed. So we're going to solve them separately, not together. So start with one, doesn't matter which one. If I'm starting with the one on the left, I would subtract 5 to both sides. Divide both sides by negative 9. A lot of these, you're going to get fractions. So just be aware of that, expect that. And then let's solve the other. So subtract 25. So we have 13x is less than negative 26. Yeah.
Would you simplify the...
Oh, yeah. Yes. Yeah, you can write the past. So divide both sides by 13. So x is less than negative 2. And then these are really helpful if you draw a number line. Yeah. So for anything that you get as a fraction, figure out what that is as a decimal. So this would be x is less than negative 1.3 repeating, just so you have that information when you make your number line. And so I need a number line that goes to negative 1.3 and negative 2, so it doesn't have to be a very long number line. Negative x is less than negative 2 would be open to the left. X is less than negative 1.3 would be like here. Open to the left. So if this is an and, you're still looking for where do they overlap? Where do these overlap? Starting at negative 2 and then onward. So that means everything less than negative 2, they're going to overlap everywhere. So that would be at negative 2. I may have also not switched my sign when I divided. Okay, so let's try it again. Okay. So now that I've graphed it correctly, that was my bad. Do these overlap? No. So if they don't overlap at all and they're supposed to, that would be no solution. Questions about that one? So and is always where they overlap no matter what. If they don't, it's no solution. If they overlap everywhere, that would be all. We're going to do one more. write down this or. Negative 9x plus 2 is greater than 18, or 13x plus 15 is less than or equal to negative 4. Solve them like normal. Okay, so we have negative 9x is greater than 16. Divide both sides by negative 9. You're going to end up with a fraction, that's okay. And switch the sign this time. And then solve the other one. Subtract 15. You have 13x is less than or equal to negative 19. And divide. Okay. Great. So negative 16 over 9 is negative 1.7 repeating. And 19 over 3, negative 19 over 3 is negative 1.4615. Just write down a couple decimals if they're repeating. Okay, so these are really close. So if we have like negative 2, negative 1, that's really all we need for our number line. This one would be closer to negative 2. And then this one would be kind of towards the middle. This one would be open, going to the left. And this one would be closed, also going to the left. With your or inequalities on Khan Academy, they aren't, sometimes they'll graph apart, sometimes they won't. Here you're looking for the union, which means where are both of these things true? So where is this true? And this would be true everywhere below negative 19 thirds. And where is this one true? Everywhere below negative 17 ninths. So because one of them is the negative 19 13ths, whatever, that would be your answer. Where are both of them true? If I'm looking at the other answers, this one is true for this one, but not for the other one, because it goes further back. This one is an and, so that wouldn't be true. What are the times where it's no solution? I've seen all. I don't know if I've seen no. I know if they're all solutions, that would be like some example where they go like this, where it would be true from one number to infinity and some number to negative infinity, so all the numbers are covered. That would be all. So as you're working on this, if you need my help, need me to double check anything, let me know. So for the remainder of class, you can be working on practice from the notes. Khan Academy, that's due tomorrow, if you haven't already, or this. Any of those, just make sure you're practicing and let me know if you